We are Improvise. We are a team from Keith Grammar School that design and build our own ROVs to use in the Mate ROV competition. I'm Lewis, I'm the CEO.
Hi, I'm Bent, I'm the Vice CEO.
Hi, my name's Dylan and I'm the CFO.
I'm Peter, I'm a technical document manager.
I'm Ria, I'm a graphic designer.
I'm Jamie and I'm a software engineer.
My name's Tom and I'm just a general engineer.
And I'm Gregor, a graphic designer.
At Improvise, working as a team is a massive part of what we do. Alongside working together, we have to coordinate ourselves as a company. Within the team, we have our own management structure and departments, where we are all able to apply our skills to the maximum potential, such as our graphic design department, where they create our poster designs. However, this also brings its own challenges, with our team each year losing crucial members. To try and combat this, we have our own recruitment process, which has been made particularly difficult this year under our current circumstances. This process, however, is where we look at our losses and aim to fill the gaps in the team.
The competition that MATE, the Marine Advanced Technology Education Centre, runs allows teams from all over the world to compete and collaborate to find solutions to real-world problems. Some examples of these problems include the death and repropagation of coral reefs, combating trash floats in oceans, and finding and fixing leaks in pipes. Alongside these tasks, we also need to make a poster, a 10-page technical document outlining everything that our ROV can do in detail, and give a 10-minute presentation not unlike this one. Also, the competition asks that we act like a company, so that we can have experience working in a corporate environment.
An ROV is a remotely operated vehicle, to put it simply. It's an underwater robot that is used to dive deep into submerged areas of water. ROVs can go deeper than trained divers, therefore it's safer to use ROVs. ROVs can be used to repair pipes and structures that are extremely dangerous and too deep to dive. As Scotland has lots of oil rigs and harbours, ROVs are commonly used near us. Commercial work-class ROVs are very big, whereas our ROV is a smaller scale work-class ROV, as we made it for a school project rather than a commercial use. The other type of ROV is an observational ROV, which is used to observe, hence the name.
When it came to designing our ROV, we started off in a planning phase, where the entire group got together and sketched their ideas on paper. Once we'd sort of colluded everything we had, we took the best aspects and made a 3D cardboard model out of them. And using this as a sort of guideline and base idea, we took it to Autodesk Inventor and made a to-scale 3D model of our ROV. We made all the components for the ROV on there, and we made one big assembly file with everything we want to include. And we still use this to add extra ideas and details as we wish.
In previous years, we've been using a pressure vessel on our ROV to house all our electronics, because we've tried electronic speed control and more complicated stuff like that. And that pressure vessel acted as buoyancy on our ROV, so we always actually had to add weight to our ROV. However, this year we've kind of gone back to basics just to make sure we've got a proper functional ROV, meaning separate flotation was needed. So we plan to put blocks of flotation on each corner. It's usually one of the final projects for the ROV, as the weight of the ROV changes depending on if we decide to take off cameras, move cameras, tooling. Obviously, depending on what tool it's on, the buoyancy can also change. So we're possibly going to take it into account and have a changeable flotation device, so it could be adding even something as small as like nuts onto the ROV, just to alter for the different weights.
On all of our ROVs, we have used build pumps that have been cut so that we can use them as motors. On our current ROV, we are using brass propellers on those motors. We chose brass propellers after we tested multiple different materials, such as our own 3D printed design, and decided that brass propellers worked best to our needed goal. We tested these different propellers on a thrust jig we made ourselves.
When it came to manufacturing parts for our ROV, we had to use many different techniques and machines to get the designs we wanted. We had to use a CNC router to carve out the shape of our frame from blocks of HDPE. We would have used a laser cutter, but because of the material and the thickness of it, we weren't able to. However, we did use our laser cutter to make the acrylic mesh and the motor guards that go in the front of the motors to protect fingers from, well, being sliced. We used a 3D printer for most of our designs, using Autodesk Inventor to create and model these components. We used our 3D printers to put those ideas into reality. We have used this 3D printer for most of the components in the ROV, including the motor shrouds, the camera mount, and our manipulator that works on a hydraulic system.
At the competition, for the tasks, we used many tools. The tool we're using this year is mechanical manipulator that uses a hydraulic system. The hydraulic system works as there's a syringe at the ROV beside them, connected to the manipulator, and one in the control box. When you push in the one in the control box, it will extrude the one down at the ROV end, which will open the claw, and when you pull on the one at the control end, it will retract the one at the ROV end, closing the claw. Most of our parts for the claw are made out of our 3D printer. We designed them on CAD software and used our 3D printer to print them. We did this as it means that if we need to replace parts, it can be done cheaply and quickly, and also that if we want to change parts like to make the claw better, we can easily change them on the CAD software and reprint.
We're using sea fish finder cameras. A camera facing down gives the pilot a view of the ROV, just anything below the ROV, I mean. This makes it easier, to traverse along the bottom of the floor of things, also for navigating towards things that will be below the ROV. And there's a camera sat parallel to the ROV base. This is mainly used when the pilot needs to use tooling, so when we might use a manipulator, a claw, anything that we're going to be using, it's just good to get an idea of where the tool is in perspective towards an object. And then finally there's a camera facing downwards. It's at a slight angle and it provides just a general flying view, as we found that's the best view.
In our team, we take safety very seriously as we're working with dangerous equipment such as soldering irons and a laser cutter. When working with dangerous things such as the soldering iron and laser cutter, we take safety precautions such as wearing protective glasses and gloves to make sure that no one gets injured.
During lockdown, we faced many struggles as we couldn't meet. We held online meetings to finish the poster and tech report. These online meetings helped us a lot and we ended up winning the competition. Now we are back at school, we have many more restrictions to follow. We can only meet up to 8 people inside with 2 meters distancing for half an hour. This gets work done, but not as much as we would like. COVID also affects the competition. As we won, we would have gone to America, but unfortunately, we did not. This year's competition will be slightly different because of this, but we hope things are back to normal soon so we can experience the competition in person.
Earlier this year we found out about a company that makes plastic recycling machines that process failed prints and waste material from a 3D print and turns them into spools to use again. This company, 3Devo, is based in the Netherlands. In total we have received 3 machines, a grinder, a dryer and an extruder. The grinder takes the plastic to be recycled and grinds it into very small pellets. The dryer will remove the moisture that was added during its last print. And finally, the extruder takes the dried plastic and puts it through a heater and extrudes it through a nozzle onto a new spool. This process takes a lot of adjustments since different types of plastic require a different heat, spool thickness and extrusion speed.
To raise funds for our team, we have taken part in many events, ranging from local events such as our Key Show, where we showed off our ROV at a small stall with live demonstration, to larger exhibitions such as the Subsea Expo, where we had a chance to meet some larger industry names and get our own name out there. But we don't just go to these events to raise funds, we also do it to raise awareness. So we presented at the SUT Christmas Lectures in Aberdeen Music Hall, where we spoke to over 500 Primary 7s to raise awareness about the Mate ROV competition. Alongside this event, we also attended the Macduff Aquarium, where we had a live demonstration in their open-air aquarium.
Thank you for watching our video presentation. If you have any questions, feel free to email us at improviserov@gmail.com. And yeah, thank you.